Hello, and welcome to Deep Learning with PolyAI. Today, we're joined by Shawn Wen, co-founder and CTO of PolyAI, who you might remember from episode 40 of Deep Learning. Hi, Shawn.
Hello, hi.
So last time, Shawn gave us an overview of the complete voice assistant tech stack. And today, we're going to take a deep dive into speech recognition. So Shawn, there's loads of really great speech recognition tools out there, right? NVIDIA, Amazon have something, Google, DeepGram, there's loads of really great stuff. So if you're thinking of building a voice assistant, surely now it's a case of just plugging one of those systems in and you're good to go.
Yeah. Well, that's in theory, that's the case. And I think that's what everybody would actually immediately think about it. I think in the past of couple of years, chatbot has actually been taking over in a lot of the contact center deployments because chat has been become more popular as a new channel. It's much easier for the contact center manager to actually managing the entire engagement between the agent and the user because the agent can jump on multiple chat threads at the same time. So it's much easier to handle it. And I think voice has been just continue to be a much more challenging channel because you have to jump into a call, have a one-on-one conversation there. So that's been challenging. Now I think chat taking over, there's a lot of automation be put into the chat channel. So therefore chatbot has becoming a thing. And then once everyone implementing the chatbot, they would want it to replicate the same success through the voice channel. And usually, yeah, that's exactly what we heard from a lot of our prospects and clients saying, hey, we have a chatbot already. Why don't we just put a voice on top of it? And then the bot is good to go. The reality is there are a lot of challenges and nuances you will probably not know, you probably won't know before you actually deploy a voice assistant. And since Poly has been deploying this kind of voice assistant several times, we have basically hit every single roadblocks in the past several times, and we kind of like operationalize the deep understanding of how to best deploy these kind of voice assistant. There are probably around 5 different major problems you'll probably run into in
Okay.
deploying voice assistant and especially converting chat into voice. There are speech recognition errors. These are probably the most prominent ones, and then you will see a lot in the deployments because these speech models are not perfect.
Yeah.
There are
With the speech recognition models, I mean, I think that's the thing that we all experience, right? When you say something to a voice assistant and it says, I'm sorry, I didn't quite catch that. And it's like the most frustrating experience when it happens, even though humans don't always understand each other, right? Sometimes we ask each
yeah.
other. Um, so how do you kind of overcome those errors? Like when it's transcribed something wrong, or maybe just not picked up anything at
Yeah, that's right, right. So I think if a lot of these experience you just described are actually very popular consumer-facing voice assist.
all.
I'm sure like Apple Siri, Google
Yeah.
Assistant, Alexa, all these voice assistant has these kind of problems. I think we will just need to be realistic is that this voice assistant will continue to have those problems. It's just like the way that you configure these speech models you can make it less of a problem. And because we are more focusing on particular things, then you will have a much easier time if you configure your speech model in the correct way. So be specific about it, right? Uh, Apple voice assistant Siri is trying to solve a very big problem. It's a consumer-facing voice assistant, supposed to be your personal assistant, supposed to be able to help with everything in your day-to-day life, and even from like singing a song, telling a joke to actually help you set the time reminder or managing your calendars. It's a quite broad range of tasks that the voice assistant needed to be doing. It's a very challenging task. Now, if you think about voice assistant in the contact center, you don't need such a broad range of speech recognition coverage. A lot of times, if you are a bank, clients calling you because they have a problem with their bank accounts, they are only limited amount of like words in the vocabulary that you should factor in there. And yeah, so I think in these cases, but by making this speech recognition tailored to contact center, even specific to particular industries, they already help you to mitigate a lot of these problems you are going to see in
Yeah,
consumer facing voice assistants.
that makes a lot of sense. But also, when I phone up customer service, I have a tendency to give far too much information or to make jokes or try and make friends with the agent for some reason.
Yeah,
Um, so I will say things that you wouldn't expect me to say, and I think that's quite common
yeah.
in voice, right?
Yeah, that's right. And to be honest, I think there are two kinds of phenomenons. One phenomenon is like as you described, you will say very very long sentences, and then this is probably like a lot of the customer we are seeing in Europe and UK because people have not get used to speaking to voice assistant yet.
Mhm.
So you are kind of like speaking to it as a person, right? Like a person on the other side, especially if we make the voice assistant sounds really like a human person, then you will actually describe it that way. Usually, this kind of this kind of long sentences, speech recognition system has a very easier time to understand because like the speech recognition system is not just taking the audio, but also the context of the previous word recognized. So the longer the context is, it's much easier for the model to predict what is the next word that you are saying.
Right.
Hope that makes sense. And so, in fact, if you speak in longer sentences, speech recognition system has an easier time to pick it up. But usually the failure happens in something down the line is what we call the natural language understanding or the intent-based models. Because the intent-based model basically try to take a sentence and classify into one of the categories. That's where this kind of error happens because long sentences has much more information, much more nuances. It's harder to classify into one of the simple categories you predefined, and that's causing the error. Now, counterintuitively, a lot of the speech recognition error happens is actually for short sentences, which is like majority of our customer we are seeing in North America are doing. Because I think in America, a lot of people have already get used to speaking to these natural language IVR systems. They know if you say long sentences, it typically fails. So they kind of learn how to say short sentences to actually make sure it works. A lot of time, even if you're sure single word sentences, it still doesn't work. It's because speech recognition systems are actually sometimes the failure more we see more is for shorter sentences. It's just because of the underlying data the model will train on. Because a lot of the speech systems will train on news or uh, a lot of these like audio book data.
Yeah.
So these are longer sentences, a lot of context. So
So
yeah,
these speech recognition models, if you look at like NVIDIA, for example, um, you get that initial transcription, which is just a sort of representation of the sounds, right, in a transcription. And then are these systems also doing that NLU layer? So are they then
that's
sort of
right.
taking the transcript and then fixing it behind the
That's
scenes?
right. Yeah.
Okay, interesting.
So I think like if you encounter a generative voice assistant these days, it's better to actually provide more context as much as possible because now ASR still be able to transcribe it very accurately for long sentences. And then the underlying LLM is going to be very, very powerful to pick up the long sentences.
Yeah, that makes sense. Like when you're listening to somebody, you probably don't hear. Like the human ear, even if you have great hearing, isn't 100%
Yeah,
accurate, right? But you're sort of filling in the gaps with what you know.
that's right. Yeah.
Um, so that makes a lot of sense. But also, I guess with users, especially in North America, like you said, where these systems have been around for a lot longer, people have got a lot more used to them. They've learned how to speak in a way that is not intuitive to them.
Yeah.
And then we're moving into a stage of technology where they actually need to go back to normal and speak how
Yeah.
they normally speak, which is an
Exactly.
interesting challenge, I guess.
Yeah, yeah. So I think one of the interesting challenges that once you plug in ASR into your chatbot, when where you will run into is that you realize that short sentences actually recognized very poorly, like the
Yeah.
yes and no, which is the most common thing. That the numbers that you say four people or like 3. And these things just didn't get recognized well. So you need to have a special treatment for those kind of terms. So what we are doing a lot is to leveraging the context information where the voice assistant is designed in. If like, give you an example, right? If I ask you a yes and no question, I expect your next turn to just like one single term, a single word. We will be able to switch to a more powerful model for shorter sentence recognitions, and you will be able to get a higher accuracy. Now, some of the APIs out there does provide multiple models for you to use. So if you look at Google speech models, for example, they have the most traditional one is called convenient search. This is basically just single turn or like shorter sentences models that have a very high accuracy on these short commands. But then there's also phone call models, which is like trained to tailor to phone conversations. And they have the typical video models, which you can imagine they probably train it on a lot of YouTube videos.
Yeah, and like I've spoken to some of our machine learning guys before, and they're finding that the telephone model doesn't necessarily work the best. Maybe the video model works best in certain
That's right.
circumstances, but then you need to
Yeah.
kind of switch between.
Yeah. Yeah. There are so many different nuances because it really depends on what kind of data this model was trained on.
Yeah,
Recently, we have been deploying NVIDIA models in-house. NVIDIA model have also several versions of their pre-trained models. We took the previous generation of the pre-trained model, adding our own contact center data on top of it. Of course, it performs a lot better for our particular use cases because the data is actually drawing from the same distribution. The interesting thing is that NVIDIA has an even more powerful model. The model size is probably like 5 times or 10 times bigger than the original one. The performance of that model on the American English is slightly better than our in-house model, but the performance of it on the British English is a lot worse. And it just tells you that, yeah, this model is probably trained on with a lot of US data, despite the fact that the model has a much powerful capability because it's a much bigger model, but it still performs worse on the British data set we have, just because the training data and testing data is a mismatch,
yeah.
right?
Well, I guess if you're thinking of building this yourself, it's not just a case of like which ASR model do I use. It's a case
Yeah,
of which combination of ASR models do I use for different parts of
exactly.
the station, and also if you really want to increase that accuracy, can you be including your data, which I guess an individual
That's
company might struggle with, but a group of
that's
companies
right.
potentially to
Yeah.
really, yeah, build that up.
Yeah, I think, the good thing about what we are doing in terms of like how we are doing it is because we're focusing on the contact center use cases.
Yeah.
So those contact center use cases are basically, on a similar, telephone lines, similar like data distribution. For different kind of clients and different use cases, we have different accents and different kind of the demographies of people, different speed at how people express themselves over the phone.
Yeah.
So a lot of this variation is quite difficult to be just covered by one single deployments, right? So we kind of have to leverage what we can, and then like since we work with a lot of enterprise customers, and we make sure that like entire data processing processes is actually compliance, GDPR, because we operate in different countries, so we have to
Yeah.
follow so many different DPA laws locally. We make sure that all these processes actually compliance, but at the same time, our customers still be able to benefit from all these data and these kind of models being trained internally.
Yeah, you kind of touched on this there, but I think one of the things that I've noticed when I listen to calls and real people talking to voice assistants is there's always this pause. The voice assistant says something, and you kind of think that the person will respond immediately, and you
Yeah,
expect latency to happen, maybe because of the models taking their time to do whatever they're doing in the background.
yeah,
Uh, but actually, people don't start talking straight away. They kind of take a second, they take a breath, and I
that's
guess
right.
how do you know when to listen out for things so that you're not interrupting people or just
Yeah.
leaving this big gap afterwards.
Yeah. I think this is a very good segue to the second problem of applying just ASR, general ASR models to contact center use cases is a latency issue, right?
Yeah.
There's a lot of like players out there are trying to minimizing the latency, right? Because like, LLM becomes very popular. Everyone's trying to do something with LLMs. Some companies put vo- speech recognition on top of LLMs and then say, oh, you can do voice assistant now. And because one of the LLM's issues that it has a high latency, although like it has been improved quite a lot
Yeah.
recently, that it becoming less and less an issue. But when it just started, it was actually a big problem, applying to a voice assistant. Now, the thing is that, a lot of these companies in the C stage try to optimizing latency for like, 100 milliseconds and things like that. The reality is when we see in the contact centers, people speak to voice system very differently. We need to be aware that we are all techies. Like when we implement the call and then try to test the system, you want to test to be as fast as possible because, like you are going to test it several times. You don't want it to wait for the voice assistant, for even just a couple hundred milliseconds. The reality is that what happened in the contact center is that some people is their first time speaking to a bot, right?
Yeah.
And and even though these people talking to bots previously, because the way we implemented it as natural as possible, they probably is the first, if they realize it's a bot, they are probably first time prompted with just a how can I help question. And then at that point you are like, am I supposed to listen one, two, or three, or like what are the keywords I can use, right? So people start thinking about it. So that's where like, if you tune that latency or optimize too much of that latency, you are at a risk of interrupting the user a lot. We have this internal evaluation we done is that, yeah, should we optimize latency a lot more aggressively? Because there are certain aspects, like you shouldn't let user wait too much all over the phone.
Yeah.
The reality is that there's no simple way out because when we look at the actual user speaking over the phone to voice assistant, some user pause longer, some users like less. The reality is that I remember if we are trying to reduce the latency by a second, you are going to increase the interruption rate to the user by probably about 15%. So that means that to reduce that 1 second, you are going to or interrupt maybe like 15% more than it used to be, which sometimes can be very frustrating to the
Right.
users.
So it's not just a technical problem, like reduce latency as much as possible. It's
Yeah,
a UX problem, right?
it is. Yeah.
Yeah,
And you
amazing.
can totally imagine that older the demography would actually have experienced more of these issues because they tend to speak more slowly, right? And then they are also new to speaking to voice assistant as well.
Yeah, I guess there are lots of just individual differences between people that make it very difficult to know because you don't know who you're speaking to. You don't know what to expect. Which again, I guess is an issue that customer service advisors face every day anyway, is that
Yes,
people are different.
that's right. That's right. Yeah.
So, okay, so you think about latency, but then you're thinking about balancing the technical side with the user experience, which is its whole own level of complex, difficult work to be doing. What is I think you said that was the second?
That's
Oh,
right. Yeah.
okay, so what's the next step?
Exactly. Yeah, I think the next thing I would say, this is probably not applying to everyone, but this is actually applying to like the companies who are actually doing in-house speech recognition systems,
Yeah.
right? Because if you're using APIs, you probably don't have too much control over it. You can just you will have to just take whatever they have and then you're just applying it. Some companies does actually have in-house speech recognition system. Like, we build a lot of in-house technology and in-house ASR systems as well. One of the challenges also managing that entire ML model production cycle. And those kind of cycles are quite different from the traditional SaaS implementation cycles. I think one of the major differences is that these models are inherently statistical, right?
Yeah.
So that would means that whenever even you try to train the model on the new data, like let's say train on 10 hours of my data, it still doesn't guarantee even 90% of my sentence is always got recognized because
Yeah.
they are inherently, statistical. That will probably also means that if I train the model on the 10 hours of my data, maybe the previous sample I provided to the system would work. The new one probably doesn't work. Is because, there's just a lot of moving parts, right? So managing this ML production model cycle is very crucial. Is that how do you guarantee that your new version of the model or new version of the system is going to be better than the previous one, right? And handling that stochastic nature of it is a very important bit of like rolling out AML systems.
Yeah. So if you want the best speech recognition, you need this certain level of control of
That's right.
being able to
Yeah,
train it, being able to adapt it, being able to improve it. And
exactly.
that's difficult to get out of the box when you're just plugging into an API.
That's right. Yeah. So, like there's a trade-off there, right? If you do in-house, there's a lot more to consider. If you do APIs, it's much easier to manage, but then you are limited to like what these APIs can do for you, right?
Yeah.
Give you an example is that one of the cloud vendors we're using. So we're using some of the APIs, some of the in-house models. Recently, this cloud vendor, I'm not going to name them, but they undergo a lot of model changes underneath. And it inevitably causing some issues. Like we see higher latency, we sometimes see some drop of the calls, and we see the degradation of performances. And even though they do actually point out to a new paper, which they published maybe like 2 years ago, and that paper says that this new paradigm of speech recognition is the way to go in the future, which is true because the major difference is they make it lexicon free. The concept of lexicon free is that previously the speech model would basically look at a lexicon of words and to say, based on this particular audio segment, it should be one of these words, right? So you're basically picking one of the words.
Yeah.
Now the model is different. It's basically generating tokens, and those tokens are sub-word units, and then you can compose them back to words later on. So it becomes a so-called lexicon-free model.
Yeah.
And in that case, some of the problems that you should not see in the lexicon models happens. For example, uh, yay, these particular words, it was always transcribed into Y-A-Y.
Yeah.
Now it could be translated into Y-A-Y-Y-Y-Y-Y because users are just much more excited and yay and for a very
Right.
long time. So it's a cool feature that now these models be able to recognize this, but you don't factor that into your language understanding components. Your assistant is going to start to say, sorry, I didn't get that. And then
That's
the user got frustrated, right? So,
the dreaded response.
exactly.
So if you're using all of these, I guess what I'm hearing is that you're maybe using this ASR model or series of ASR models. They've been working really well for you, but if
Yeah.
that provider puts through an update or makes any changes to their models, that could
Yeah.
potentially have an impact on you. So you need to be
That's right.
on top of what all of these vendors are doing, all of the updates that they're making, all of the sort of fixes, and your
That's
customer
right.
experience all at the same time.
Exactly, exactly. And I think a lot of times, these general speech APIs are not all for contact center use cases, right?
Yeah.
Like, sometimes they use for, subtitle purposes.
Yeah.
Sometimes they are using for, different kind of like maybe audiobook transcription or news transcription. So there are different purposes. So there are general purpose models, which is actually very powerful for
Yeah.
general use cases, but it's not necessarily tuned for your contact centers use
Yeah.
cases. And sometimes their updates or changes is also not necessary in the interest of that particular segment of their clients. So yeah, that's
Yeah.
the challenge.
Okay. Well, that's 3 out of 5 things, and I feel like it's
Yeah,
too much to keep in my head.
it
It's
is
difficult, right?
challenging. Yeah, yeah, exactly. Yeah, well, I guess like, the next one is probably like a obvious one, which
Okay.
people don't usually pay attention to.
Okay.
And this is actually, I mean, this is probably less related to speech recognition per se, but it's more about like the user experience design. When you put a voice on top of the chatbot and then wanted the chatbot to actually act as a voice assistant, one of the major challenges usually people run into is chatbot is very talkative, right? Because the way of the chat channel, I can actually speed up a huge paragraph of text, and then the users can read through it, maybe click on some links, and then go to even bigger piece of like document. In voice, you cannot do that, right? The voice channel is a very narrow channel in a way that the information exchanged it's not, you cannot do multimedia. You cannot really wait for a long time reading through a piece of paper. So it's a very different kind of channel. And then because of that, and if you think about it, right, if you're on call with a contact center agent, if the agent for some reason silent for 3 seconds, you worry a little bit, and then you started to freak out because like it's the person dropped out of the call.
Yeah, yeah.
Do I have to go through that wait time again, right? But they just like silent there doing their thing for you, right? So because of that, that user touch is super important. So if you have a bot that just say whatever the chatbot says back to the user is going to be like lose track of what the bot is talking about.
Yeah.
And then they have to repeat themselves again.
Yeah, I remember, like, really early versions of PolyAI, right? I'm talking many years ago,
Yeah.
when we first met, that, a customer might ask or a user might ask, "What are the opening times for this, restaurant? When do you open today?"
Yeah,
And
yeah.
the bot will reel off, like, "On Mondays, we're open this, on
That's
Tuesdays."
right. Yeah, yeah, yeah.
And it's like that was kind of the only way to get that information without having to create all of these different intents and go through all of this work that was gonna be really difficult for the client basically to
That's
pay
right.
for and manage.
Yeah, yeah, exactly. So I think, being contextual on the voice channel is super important. Like understanding context, not just about like pre-generated cam sentences and then read it back to the customer is super important. So I
Mm.
think that's the fourth point that I would say that, it's very important to kind of consider as well.
And I guess it doesn't always feel intuitive, right? There's different. I mean, we have a whole team at PolyAI of dialogue designers who are thinking
That's right.
this stuff in a project. It's not a case of like, well, I speak to people every day. I know how to, I could do this.
That's right. Yeah, yeah, yeah.
Not always
In
gonna.
fact, dialogue designer, we actually create that job title
Yeah.
and that entire organization after we realized this is super important.
Yeah, 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 yeah. It's, something that seems like it should be very intuitive, right? And then when I speak to our dialogue design team, it's always fascinating to see the level of work and research that goes
That's right.
into making this actually work.
Yeah, exactly.
Cool. So the last thing.
Last thing is probably the most boring thing of the entire map, but it's also worth to consider as well.
Okay.
And I like to call it like the utilities of voice assistant, right?
Mm.
Like the utility is like, you have a house, you have the water, electricity, you just expect it to run and then you don't pay much, that kind of things. This is about telephone, right?
Right.
And once you get into contact center, you realize that telephony is actually a very messy bit. Like when you build a demo, you will be able to use the modern technical platform like Twilio. In
Yeah.
fact, we are actually great partners with Twilio. We have a really strong relationship with them. And we like to use Twilio as well. Like all our products have built like around it. These kind of telephony providers make the entire create softwares that make telephony very simple, super easy to do. Right? But there's still certain limitations. One of the major limitations when it comes to play is always the case. I remember our first deployments we launched it with the Twilio voice feature. Clients really love it. But then at some point, they realize there are some latencies in between. And those latencies are basically because underlying the Twilio software, Twilio is actually talking to different telephony partners in the UK. So there are additional like telephony wirings happening underneath, which
Right.
is not apparent to a developer like us. So then those latencies caused that causing some, those kind of configurations causing some underlying latencies.
Yeah.
So that's one of the problems. There are other problems, for example, when the telephony service has an outage, which still happen unfortunately sometimes, then the client would expect to have a reason why there's a outage happening. And Twilio, because they work with several partners underneath, they can't really share the full details of these telephone
Mm,
like outage reasons. And that becomes a little bit difficult to work with our enterprise customers because enterprise customers, they want is like if there's a issue happens, they at least need to know the root cause and then making sure that won't happen again. And
yeah.
that's just sometimes not easy to get. Another major issue is that if you use advanced platforms like Twilio, and not just Twilio, right? I think all the Vonage and easy to use platforms, because their business model is not selling you the utility, is the ability to create those utility apps very easily.
Yeah.
So they charge you quite a lot on the utility, right? And there was certain point of one of our customers, a huge volume in UK. Because usually if they wanted to use the Twilio configuration, we would just say, okay, we will pass on the telephony cost to the clients because they will pay for that utility because, that's the utility serving their contact center, right? At some point, our client actually paying much more to Twilio than to us. And just because I think the utility itself at that stage, because they charge by the usage, it becomes
Right.
much higher, right? And so I think, therefore, like we have shifted towards a strategy is that we have our own in-house telephone system, so that we can connect it to our voice assistant and we can connect it to our client because that entire thing is through the internet. We don't charge the client anything, right? So it's like just the real utility, for everyone. We do actually have a convenience of the Twilio solution because the Twilio solution is much easier to integrate. Client doesn't have to engage their IT team to do the
Yeah.
integration with us because that's very straightforward. So we have these two options. And that just tells you that in order to actually be like enterprise ready and then be able to like serving client in a way you wanted to serve them, you probably also need to own that telephony technical stack as well.
Oh, wow. So if you're building this yourself, you know,
Yeah,
build your
exactly.
own
And
telephony system.
several years of building it, making sure that it's, highly scalable, highly reliable, very cheap, so the clients
Yes.
don't have to pay for any single dime of it.
Yeah. Wow. Okay. So there's a lot. There's understanding the speech recognition errors and being able
Yeah,
to kind of fix
yeah,
those on the fly. There's handling latency, but not just latency, but also
interruption.
interruption. Yeah, the opposite of latency.
Exactly.
Um, and then you've got your sort of product iteration cycle, really understanding how your vendors are working with their products and what
Mm,
impact that has on you.
that's right.
Then you've got your dialogue design. So these things that should feel intuitive decisions that you can make when designing how this works, but
Yeah,
realistically, a bit strange. And then you've got telephony utilities. So this whole other level of admin and cost and
yeah,
IT people needed to make all this work. And this is just the speech recognition layer.
that's
I think
right. Yes.
we have about
Yeah, just at the very beginning.
right at the very top. Okay, well, Shawn, thanks so much for taking the time to talk this through today. This has been really, really, really useful. And let's talk again really soon. Let's talk about the next layer, which I think is LLMs.
Yeah, no problem. That'll
Okay,
be fun.
so yeah, stay tuned for a future episode on LLMs. Until then, thanks for joining us at Deep Learning.
See you soon.